Water, one of the only molecules that exist in solid, liquid, and gaseous state naturally on planet Earth. Water is very interesting. For example, under solid H2O, you have two main categories: ice, which is crystalline, and amorphous water, which we will discuss in this video. Now, what is amorphous water? Well, like all substances, water does have a non-crystalline solid form, amorphous water. Here, the molecules of H2O are arranged in a somewhat chunky manner. There might be certain parts where the molecules have crystallized, but as a whole, they do not align themselves in a single crystalline structure. This means that this form of water is denser than liquid water. But if ice and amorphous water are both solid forms of water, why don't we find amorphous water in our refrigerators or in the polar ice caps? That is because these two forms of water form at different temperature or under different pressure ranges. It is this temperature-pressure relation that defines which solid state water will form. Now, before we continue, we must understand what glass transition temperature is. This is the temperature range to which any crystalline or semi-crystalline structure must be rapidly cooled to form an amorphous solid. This is how the glass of your window panes are made. This also means that technically you can make glass out of water. So, how can you make amorphous water? To make amorphous water, you need to cool water to its glass transition temperature rapidly. And by that, I mean in about a couple of milliseconds. For water, this temperature is around 137 Kelvin or about minus 137 degrees Celsius. The pressure applied on water during this freezing process is also extremely important. It defines the different types of amorphous water: low density, high density, and very high density amorphous water. Pressure can also help turn crystalline ice into amorphous water. Now, due to the extreme temperature pressure ranges that amorphous water forms in, it is most common in outer space. It is, in fact, the most common form of H2O in the universe. Despite this, no, you will probably never see amorphous water near or around you, and you can be sure that the ice cubes from your refrigerator will not sink into your lemonade. Thank you for watching, and I hope I was able to share something new with you today.